All right, we're down to the last section of this review. Cool. So, number 13, which of the following is correctly balanced? You already know that the mass numbers and the atomic numbers have to match each other on both the reactant and the product side. So let's start figuring this out. On the reactant side, I have 238, and on the product side, I have 232 plus 4, which is 236. Right off the bat, I can see that 236 does not match 238, so I can safely cross out 8. Next one, I have 249 plus 15. That is 259, 60, 61, 62, 64. 264 mass number on this side. And then I have 260 plus, oh, and this, you've never seen this before, huh? This coefficient will multiply this, so that's actually a 3, a total of 3. So 260 plus 3 is 263. So now I look and I'm like, well, 263 does not equal 264, so it is not B. Then I look at C. I have 2 plus 3 is 5. And then on this side, I have 4 plus 1 is 5. Ooh, my 5s finally, or my mass numbers finally match. Both are 5. So now I'm going to look at the atomic number. 1 plus 1 is 2. 2, well, I don't know why I wrote that 2. 2 plus 0 is also 2. Wow, so my atomic numbers also match. This is looking like a really good answer. Wait, did I make a mistake here? I think I did. So I said 2 plus 3 is 5 and 1 plus 1 is 2. This side is fine, but look here. Did you catch that mistake while I did it? If you didn't, look, because I made the same mistake. There is a coefficient here, and this coefficient is going to multiply this mass number. So 2 times 1 is 2. So this is actually 4 plus 2 to equal 6. So 5 and 6 do not match, and I can cross this one out. Silly Miss Rodriguez did not catch that sooner. Wow. If you did though, props to you. You should take a nap today to congratulate yourself. All right, last one. 238 plus 1 is 239. I have 239 on my reactant side and 239 on my product side. That's matching. That's good. Check. I have 92 plus 0 is 92 as atomic number on my reactant side, and I have 92 on my product side. So 92 matches with 92, and that looks like a really good answer, and it's the only answer left, and they're balanced, so it is probably D. All right, this next one, which metal will not react with hydrogen? You're going to need to access the activity series chart that you have under your reference tab in OneNote, and it is in your resource sheet. So it should look like this. How you read this is that anything that is above, there it is. This activity series is showing you what reacts with hydrogen. As you go more up, things are more likely to react with hydrogen. Notice that it says hydrogen right here. So this is the cutoff. So things above hydrogen will react with hydrogen. Things below hydrogen will not react with hydrogen. So for number 14, it is asking me which will not react with hydrogen. I just have to find which one of these metals is going to be below hydrogen. Things below hydrogen will not react with it. Things above it will. Things below will not. So lithium. Lithium is up here. It is above hydrogen, so it will react with hydrogen. Therefore, it is not my answer. Iron. Iron is right here. Iron is above hydrogen, so it will react with hydrogen. Therefore, is not my answer. Copper. Copper is down here. It is below hydrogen, so it will not react with hydrogen. Whoops. So this is looking like a really good answer. Last one is aluminum. Aluminum is up here. It is above hydrogen, so it will react with hydrogen. So it is not my answer. My answer is C. Next one, I have to balance an equation. So, this is going to be a hard one. Are we ready? Are we ready? Alrighty, so I have nitrogen, oxygen, and hydrogen on my reactant side. I have nitrogen, oxygen, and hydrogen on my product side. On my reactant side, I have one nitrogen atom, and I have two oxygen atoms, and I have 4 hydrogen atoms. On my product side, I have one nitrogen atom, I have 1, 2, 3 oxygen atoms, and I have 2 hydrogen atoms. So I see that stuff is already messed up. So I have 4 hydrogens here and only 2 here, so let me start with that one. It doesn't really matter which one you start with, it's all kind of just random, so if you can't figure it out, just keep trying numbers. So I'm going to multiply this one by 2, that means that this 2 coefficient has to go in front right here. So now I have 4 hydrogens, my hydrogens are matched, but this coefficient also multiplies this oxygen. So now I have 2 oxygens plus 2 is equal to 4. 2 plus 2 is 4. So now I look at this side and I'm like, well, I have 2 oxygens over here. I can multiply this one by 2 to equal 4. To do that, I have to put this 2 coefficient in front of this oxygen. And now I look and I am absolutely balanced. I have 1 nitrogen on both sides. I have 4 oxygens on both sides, and I have 4 hydrogens on both sides. Circle the reactants in the above equation. I know a reactant is anything to the left of arrow. So things that are to the left of the arrow are oxygen and ammonium. That's ammonium. Highlight the products in the above equation. I know that products are anything to the right of arrow, and that is nitrous oxide and water. Actually, this is nitrogen dioxide. All right, cool. So I did number 16 and 17, pretty easy. Reactants, products. To the left of my arrow, reactants. To the right of my arrow, products. All right, almost done. Which states of matter are visible in this reaction? And it's referring to this one. So states of matter are the things in parentheses. So I see an L there, that's liquid. I see a G here, that's gas. I see another G, gas, I already wrote it down. And I see another L, liquid, I already have it down. Boom, you're done. What type of reaction is this? Okay, so let's see. I have a carbon hydrogen thing and oxygen, and it is making carbon dioxide and water. These products should like ping your head and be like, whoa, carbon dioxide and water being made? That is a combustion reaction. Remember, for a combustion reaction, you start off with a hydrocarbon, meaning a carbon-hydrogen compound, which we have. You reacted with oxygen, and it blows up and it comes on fire and it produces carbon dioxide and water.